Hello, hi everybody. It is day 19. Let me change this. It is day 19 of studying math in every day, and today I'm about to do a session. It is also Friday, and I don't even study on the Fridays. Even like today was like it is still holiday, you know. We are in holiday days, okay? So it's Eid, but this is like the last day of the Eid. This is the third day. So today, I don't have like any plans. I'm thinking about studying this lesson, multivariable rational equations, or just let me start the timer first of all. So the first thing that I'm thinking about is just like taking this lesson, okay, which says multivariable rational equations, or maybe watch a video from Professor Leonard, one long ass video from him. You know, I'm thinking both of these two choices. You know, let me just check this one. It looks like it's not that complicated. And it won't need that much of reasoning. I think, and they are utilizing the exact same techniques that I have used for like rational equations back in like like for previous lessons somewhere right here. Rational equations, yeah, they're gonna utilize these uh techniques to solve. So right up. So what should I decide? Let me try if I can find a good video from Professor Leonard. Professor Leonard. But should I take this lesson? Let me check.
Slope, this rise over run thing. Now it's time to find the formula. I am not the type of teacher to just give you a formula without showing you exactly where it comes from. I don't think that's worth anything.
Maybe I'm about to take. Although I'm not studying like slope recently, but like, yeah, it is one of the pillars of like the main pillars of algebra, right? I felt like watching one of these lessons, even this one, I believe, when I was in algebra 1, but I don't remember. So yeah, this will be like theory lesson. It won't be like, you know, a lesson that he will be solving some problems and stuff.
We're going to discover where the slope formula comes from. Why does it look the way it does? What's it do for us?
But is this a new version? Like, I mean, is this a new feature? You can ask something about the video, summarize the video. Wow. Wow. Google is cooking. They're using Gemini under the hood, right? For sure, yeah.
that comes from and what it's really doing will make less mistakes when we're plugging in numbers. Frankly, that's what it is. So let's talk about discovering what the slope formula is. So what you've noticed on the board right now, I've got a random line. Yeah, we can say the slope is positive as we move from left to right. We're climbing. We have a positive.
Happened to my network. Is it bad? It's bad.
Rise
I'm dealing
and a
with this type
positive
of
run, course, moving to
issue.
the right, but I'm not concerned about that.
I'm about to go to them and ask them. I cannot find steady. Oh my gosh.
What I'm concerned about is a way that's going to allow me to find the slope between any 2 points on a line without having to draw it, without having to look at it, without having to count up and over. And I'll show you that in a little while, next video.
Okay, I think this is unusable if I'm...
But that's what we're getting to. So let's start with random line. Now, let's put 2 points on this line. We know that we've got to have at least 2 points to even make a line. So we're going to have 2 points to also find the slope of that line. So this whole slope formula is predicated on the fact that you got to be able.
Okay, I'm gonna put it 720. 720B.
able to find 2 points to find the slope. Let's create some points. Now, as we move forward, please don't miss this. I'm not picking specific points here, because if I pick specific points and try to find a formula for that, what's going to happen is that formula is only going to work with those specific points. So I'm going to pick 2 random points. Let's call them A and B. And we're going to be finding the slope between A and B. The slope between A and B is going to be a slope between any 2 points. The slope never changes. It's a constant rate of change that our line is increasing forever or decreasing forever. That's why we get a line. If we alter the rate of change from point to point, we no longer get a line, we start getting curves. The study of the slope of curves, what? It exists. It's called calculus. When we get to calculus, we study what the slope of a curve at a point is. Very interesting stuff. We study what the slope of a curve at a point is. Very interesting stuff. It's kind of magic. It's really cool. I hope you get there. I really do. I love it for you guys to make it past this and get to the stuff where you get to do cool math. Not that this isn't cool, but it's more cooler later. Anyhow, the slope of a line doesn't change. So if we find the slope between A and B, we'll find the slope of the line between any 2 points. So we're leaving A and B as I don't know what those points are. Frankly, I don't even care. We're going to find the slope. Now, think back for a second. If you plotted a point, if I said, hey, plot point A or plot point X, whatever, what would you need to know in order to plot that point? Well, you need to know coordinates. How many coordinates does every point have?
Oh.
If we're talking about a flat surface, a rectangular coordinate system, how many coordinates does every point? You need to know coordinates. How many coordinates does every point have? If we're talking about a flat surface, a rectangular coordinate system, how many coordinates does every point have?
There's
Yeah,
2.
they got 2, and X comes first, and Y comes second. So every point ever has an X coordinate and a Y coordinate. Let's put those up there. So if every point ever has an X coordinate and a Y coordinate, that means A has an X coordinate and a Y coordinate. And that means B has an X coordinate and a Y coordinate. And right off the bat, you might notice a problem. Because if I say, hey, that's the point XY, and that's the point XY, and I'm talking about 2 different points, that's a problem. Because there's no way to distinguish between the 2 points. Do you see that? Do you see what I'm talking about? Do you see that if I say, hey, go to the coordinate X, you go X coordinate and a Y coordinate. Point XY, and that's the point XY problem. Because if I say, hey, that's the point XY, and that's the point XY, and I'm talking about 2 different points, that's a problem. Because there's no way to distinguish between the 2 points. Do you see that? Do you see what I'm talking about? Do you see that if I say, hey, go to the coordinate X, you go, well, that's a problem.
That's why X1 and Y1, like using, I think it got a name, you know, when we saying like X1 and Y1, they use some type of a terminology for this, yeah. But like I think is this when x1 y1 x2 y2 thing comes into the place, because like just to distinguish between the 2 points, right?
What we're going to do is we're going to give this thing a subscript.
Yeah, this is what they call it, subscript, yeah.
Superscripts that are written above and to the right of the variable are reserved for exponents. Subscripts tell you what exponent or what variable you're talking about. That's a way to number our variables. It doesn't really do anything besides say, hey, this is the first one, this is the second one. So we're going to do that. So instead of just x and y, let's call this x1 and y1 because, well, it was our first point. Now, before you ask a question, I always get asked this question. Does it matter which one is your first point and which one is your second point? Which one you call x1, y1, and which one you're going to call x2, y2? Does it matter?
Nah, it doesn't matter.
No. The slope formula does not care what order you have your points. It's going to work out either way that we get the correct slope. That's kind of nice. So no matter what order your points are given in, it doesn't matter. It really doesn't matter. One of them's called the first one, one of them's called the second one. That's kind of nice. Oops, I made a big mistake. Don't do this.
Yeah.
Please don't do this. If you're going to have
Like, yeah, this will be a mistake. Yeah, like if this is x1, this should be also y1, not y2. Okay.
a point, it needs to have an x coordinate and a y coordinate that have the same subscript. So we'd have x1, y1, not x1, y2. Please don't do this. If you're going to have a point, it needs to have an x coordinate and a y coordinate that have the same subscript. So we'd have x1, y1, not x1, y2 like I wrote. So this is our first point. x1, y1 says, hey, let's consider that to be point A. And then x2, y2, let's consider that to be point 2. Now, why don't I have specific points again? Why don't I want to put up there, that looks like 1, 2, maybe, I don't know. That looks like 5, 6, whatever. I don't want that because then the formula that we're about to create would only work with those points. That's silly. I want a formula that has x's and y's in it. x1, y1, x2, y2. That way I can plug in any 2 points and it will give me, without graphing, what the slope is. That's awesome. That's what we're trying to do. So I call this one x1, y1, this one x2, y2, just to distinguish between the 2 points that we have to have. Now here's the big deal. All we know about slope at this point is that slope is a ratio, and then it equals rise over run.
Yeah.
Now, if we're somehow able to identify the rise and identify the run with these points, then we can go ahead and translate this. That's a formula, that's the first one. If we know slope is rise over run, and we know what the rise is,
which is like
considering
dy,
our variables, and we know what the run is, considering
which
the
is
variables,
the
so we can
x.
translate this to a formula. Now, I want you to think back. What is the rise? Is the rise
It is the
the
vertical.
vertical component or the
Yeah.
horizontal component?
It's the vertical
Kind of makes
component.
sense that if we're rising, we're
It's the
talking about going up
vertical
or down.
coordinate.
Negative
Right.
rise would be falling. That's how to interpret this whole slope idea, with rise being positive means up, negative means down. Now, what variables do you think would have to do with rise? I mean, if rise is talking about this way, what variables talk about this way?
So why?
Why? Yeah, for sure, why? So all we've got to do is figure out the y components for this point and the y component for this point and find the difference between them. So let's go ahead and let's try that. This is weird, but how high is that point? In other words, what I'm asking you is how far up on the y-axis would you have to go to reach the level of this point? So it's not at 0. It's not at this level. It's a little bit higher. You could probably stop or put your.
What did he say?
Is how far up on the y-axis would you have to go to reach the level of this point? So it's not at 0. It's not at this level. It's a little bit higher. You could probably stop or put your pencil where the level is. If you hold it this way, right there, I would stop at the level. This would be the level
Let's make
or
it.
the height of that point, considering just the vertical movement, considering just along the y-axis, and that is precisely what RISE does. RISE only cares about this way. That's all it does. So I need to know how far up this point is. So how far up this point is right there. How far up this point is, well, let's do it. This rise was right about there, or this y component, the coordinate was right about there, and the component of point B is probably right about, looks right about there. Does that make sense to you? Does that make sense that that's the height of those 2 points? You go, well, yeah, it's points here, it's about that high. Points there, it's that high. Now, here's the big part. What's the component of that? Oh, I mean, like, how high is that really? I don't want you telling me 3. I don't want that. It looks about 3. Because then you could only use 3. I don't want that. I want to know for any point what the height is given by. Think about that as we go ahead and we do our x's real quick. I want your brains kind of thinking about that right now then. So now we need to know the run component. Oh, the part on the x-axis. So how far over our point A is. Seems to me that this is about, okay, well, it's not here. Looks about, almost gave it away. There and there. That, as far as the x-axis, would give you where we are for this point and this point. Remember that we're on a rectangular coordinate system. We have 2 numbers for every point. An x number, how far over we are on the x-axis, and a y number, how far up we are on the y-axis. So x and then y. Let me make it kind of easy, because I lose students right here when I just give this away. So I want you to pretend, it's not the point, but just pretend that this is the point 3, 4. Just pretend. I'm going to erase that in just a minute, okay?
You're not that bad.
Let's pretend that's 3, 4. What would this number be? Right there.
Okay, it will be the 3, right?
We've gone backwards and forwards in points. Do you remember that? We went and we plotted points from their coordinates, and we got coordinates from their points. Basically, we're doing the latter of those two. So if I tell you, hey, that point's right there. That's right there. 3, 4. That's 3, 4. What's this part? How far would you have to go over to get to the point 3, 4? X, oh, whoa, that's kind of cool. The x coordinate is 3. I'm talking about how far over we are on the x-axis. This is not unimportant. This is really key that you get this. That number, that 3, tells you this number. Do you get that? The x coordinate literally does mean how far you are over on the x-axis. I know we've talked about that, but sometimes it never sinks in till like right now. So that number gives you this number. So that's 3. If this point is 3, 4, that number is 3. How far are you over on the x? How far up are we then? Seems to me to be the y coordinate. We'd be up 4. And that's exactly how we get to that point. If you start at the origin, say plot 3, 4, you go over 3, you go up 4. That's exactly what we're doing in reverse. Now, we don't have 3, 4. But what was important is this. The x coordinate literally tells you how far over you are on the x-axis. The y coordinate literally tells you how far up.
How far up, yeah. You are over the y-axis.
We are on the y-axis. So now put your brains in variable mode, okay? I don't have 3, 4. I don't have this as an actual point, so I'm not going to put 3, 4 down. I don't want to ruin that for us. I want to give you, it's not 3, 4 anymore, but it is specific. It's x1, y1. And when we put those subscripts down, we are talking about a specific point. So it's going to have actual numbers. And I'm not talking about x and y as variables right now. I'm talking about this is an actual point. x1, y1 gives you real numbers. You're going to put those in there. So we're not talking like something that can change when I have a situation of 2 points. Those 2 points are 2 freaking points. So let's pretend it's like 3, 4. I knew that if this was 3, I had 3. If this was 4, I had 4. Now I don't have that, but I still have numbers. What's this number? So it's no longer 3. What is it?
Oh.
what the x-coordinate tells you is how far over you are on the x. So if you have a point with an x-coordinate of x sub 1, 3, 5, negative 2, who cares? It's telling you how far over it is. So if I give you a point of x1, y1, your x-coordinate is how far over you are on the x. That's gotta be x1.
Yeah, that's fine. That's fine.
X sub 1.
Let's take
Which
this
means
one.
that our
Okay.
height is given by the y-coordinate, y sub 1. Why don't you right now try to fill out the other ones? How far over is this?
You know, this look is so simple to me right now because it's just like something that's some type of maybe me reviewing something, maybe just like rewatching all the lecture. But like, dude, at the first time that I was studying, like, oh my gosh, it was just like so hard for me. I even like think like this. I don't know if I'm gonna write about this, but like I think I never heard of anything which is called slope back in high school or maybe even like middle school, to be honest, primary school. That's what we call them. Like, dude. Okay, sorry. Okay, I'm starting. Do we have like something else? Do we have another name which is called slope in Somali? Because like I'm Somali, right? Do we have something else which is called slope? Why did I never ever heard it? Like I never heard of like slope in my entire life. Okay. This is like I got into this slope thing when I just started studying algebra, like and doing self-study, you know. So, dude, oh my gosh, like I'm about to call somebody that I know who is so good at maths. Is my uncle. I'm about to call him and ask him, like, if that's the case. I'm gonna ask him if they call something else slope in Somali. They call slope something else in Somali. So, right up. Because like enough, dude. I'm asking this myself. And Ahmedo, iska waran. Alxamdulilah, waxaan ku weydiinaya adeer. Horta ma in slope ma af Soomaali ma wax kale lagu yiraahdaa? Yani manhajyadeena maxaa ku qoran slope af Soomaali ahaan maxaa ku qoran? Yeah? maxaa ku celi? Tanjeer. Marka tanjeer baa la yiraahdaa iyo slope looma yiraahdaa miyaa marka slope uguma yeedhaan? Oh, so that means maxaa la yiraahdaa slope intii iskuul ku jiray weligiis slope iyadoo la leeyahay ma maqal. So marka tanjeer baa la oran jiray. Oh my gosh, that's weird. Balwaay imika waxaan isweydiinay weybaad weligaa u maqan maxaa la yiraahdaa slope marka iskuulka dhiganaysay. So but hey tanjeer, okay. Ma dhiga jirin damas maaha, yeah, for sure. Damas maaha, damas waxa ma baran jirin. Yeah, okay. So yeah, I asked him and he said like they call it something else. They don't call it slope, so they call it tanjeer. I never even heard tanjeer. Dude, I don't know what I used to do like when the math teacher is in the class. I don't know. Do I used to sleep? Oh my gosh. Let's continue.
X coordinates always give us our distance along the x-axis, how far we are from the origin. Then this must be given by the other x-coordinate. It should be not common sense, but it should be kind of intuitive here that the x-coordinates have to do with the x-axis. It tells you where you are. And the y-coordinates have to do with the y-axis, tells you where you are. We're actually really close. So here's a little recap. We know that slope is rise over run. The comparison of vertical motion along the y-axis compared to horizontal motion to the right along the x-axis. Slope always reads from left to right, which is why the run is always to the right. That's what we're talking about here. I'm starting with 2 points. I don't know what they are, but I do want specific points. I do want to be able to plug in specific points. That's the x1, y1 for the first point, and x2, y2 from the second point. Does not matter which one you call x1, y1 or x2, y2. Doesn't matter. What does matter is that we understand your x-coordinate gives you your distance on the x-axis for both points. Your y-coordinates tell you the distance on your y-axis. If you get that, if you're with me still so far, that is awesome, because we are almost done. Let's talk
Yes, I'm with you. Okay.
about the rise first. You see, if the rise is just the change in height, vertical motion, from one point to another, then really our height is just the distance from, well, A's got a height right here. That's cool. That's the y coordinate. B's got a height right here. It's just that distance. You can make a little dotted line if you want. Kind of missed, but forgive me. The vertical change, the rise, is just the distance from those two y's, those two coordinates, the y coordinates. Does that make sense to you? That if we're talking about...
So, let me just like finish the whole session right here. Okay. Today my session was not like studying something new or maybe like doing a whole session. So let me just finish it right here. Maybe I studied like, I don't know, yes, 25 minutes. So yeah, it was day 19 of studying math in every day, and all I wanted to do was like to keep the aesthetic on. You know, I didn't want to break the chain. So I'm gonna finish the session right here. So it was day 19 of studying math in every day, and yeah, see ya tomorrow. I will be, you know, working my ass off, and I will be studying at least 2 sessions. So I want to go back to work tomorrow, inshallah. If Allah, you know, if God wills, you know. Yeah, we don't know if we're gonna wake up tomorrow well-being. So see ya. Okay, see ya all.